Unit 1, Lesson 3, Parallelograms. Before we begin, you need your Unit 1, Lesson 3 notes packet, a pencil, and your headphones. If you do not have these items, please pause the video and then come back when you're ready. Our learning target is, I can find the area of a parallelogram and describe its features using math vocabulary. Okay, a parallelogram. A parallelogram is a type of quadrilateral that has two pairs of parallel sides. A quadrilateral is a shape with four sides. And it's important to remember that parallel lines never intersect each other. They will go on forever and never touch. So opposite sides are parallel. So side B, the two side B's are parallel to each other, and the two side A's are parallel to each other. And we have four sides total. Other features of a parallelogram. So things to note is the opposite sides of a parallelogram have equal length. The opposite angles of a parallelogram have equal measure. So here are two examples. The first one's already labeled for you, but we can see that the top and bottom sides are both 5, and the two other sides are 4.24. So they're not all four equal to each other, only the opposite sides are. Sometimes they can all be equal, but it's not always the case. And then opposite angles of a parallelogram have equal measure. So if you see, opposite is diagonal. So opposite is all the way on the other side of that shape. So you can notice that these are both 45. And opposite that are two 135-degree angles. So opposite angles are always congruent or equal measure. And then opposite sides are also equal length. So let's do the second parallelogram together. I know this is a parallelogram. It's given. So if I know it's a parallelogram, I automatically know that it has these two features, no matter what. If this side and this side are 4, if this side, we know that they're 4, they're equal to each other. If I know that this side is 9.34 units long, I know that the other side is also 9.34 units long. These two angles are congruent to each other. I keep on using that fancy word. What I mean is they have equal measure. So the opposite angles will have equal measure. So if this one's 152.8 degrees, that means the other angle is also 152.8 degrees. Just so you can look at that all nice and clean. Oop, I took up all my pen options. Okay, moving on. Finding the area of a parallelogram. So strategy 1 is we can decompose and rearrange a parallelogram to form a rectangle because we know how to find the area of a rectangle. It's length times width. Here are 3 different ways that we can look at we can decompose the same parallelogram and decompose it. So there's no just one answer. The first example takes this parallelogram, which is the blue shape, and cuts off this triangle right here and moves it over here. And then they form this new rectangle that's easy to calculate for. So this would be the new shape. Same thing with the next one. Instead, they cut off a different part of the parallelogram. So they went on this side instead and moved it over here. So it doesn't matter what part you take off, as long as you put it back together, just like we learned in lesson 1. No matter how you cut it, if you put it back together, you're not changing the total area. You're just rearranging it. So here's another rectangle that was created using the same parallelogram. Or you can cut it even in a funky way. They made 2 trapezoids here, and what they did was they moved this trapezoid over here and still created a rectangle. All of these rectangles are 3 So this is 1, 2, 3 units by 1, 2, 3, 4. And 3 times 4 is 12. And that is the case. It's kind of hard to see. And that is the case for all of these. These are all 3 by 4 rectangles. And 3 times 4 is 12. So the area of this parallelogram is 12 square units. Strategy number 2 is we can enclose the parallelogram and then subtract the area of the 2 triangles in the corner. So we have the same exact parallelogram as in the first strategy, except what we did was we put it inside this giant rectangle. We just enclosed it. The total area of this triangle is, this side is 3 units by 1, 2, 3, 4, 5, 6 units. And 3 times 6 is 18. So that's how big the rectangle is that we drew around our parallelogram. But that's not the size of our parallelogram. We need to subtract these extra triangles that we drew, that we created when we enclosed it. So whenever we take these 2 triangles that we drew and put them together, that is a 2 by 3 rectangle. Yep, 1, 2, 3. And that is a total of 6 square units. So to find the area of our parallelogram, we would take the 18, subtract the 6, and our remaining parallelogram is 12 square units. Is that the size of our previous one? I can't remember. I think it is. Okay, moving on. So 12 square units. Both of these strategies work for any parallelogram, but we should pick the easiest option. For example, this one is kind of harder. That's a bunch of little triangles to put together. You can do that, I guess, but to me it'd be easier just to enclose this in one giant, rectangle. So whatever strategy works for you, both would give you the correct answer. All right. And that is the end of our lesson. So next up, you need to work on your check your understanding problems, rate yourself on your mastery of the success criteria, complete a should do activity if you need extra practice, and then complete your mastery check at the mastery check table. If you are waiting to take your mastery check, or you're waiting for me to grade your mastery check, you can work on iReady My Path. Good luck!